Thank you for coming. My name is Gabe, and I'm coming from Vancouver, Canada. On GitHub, my username is Garbles. And if you have any questions after this talk that you don't get into the Slido, you can email me at reactive@gabe.pizza. I work for a company called Unbounce in Vancouver. We make marketing automation software for people who do online marketing. And today I'm going to be talking to you about property-based testing. So property-based testing is something that's quite popular in a lot of languages, like Haskell, Erlang, Scala, not so popular in JavaScript. And there are good reasons for that. But I'm going to talk about how we make it work at Unbounce. And the thing is that it can often be much more effective than the typical example-based unit tests that you're used to writing. That's why I'm really excited to sort of share this with you today. And really, I'm only scratching the surface of what's possible here. So yeah, let's just dive into it. And so I'll sort of posit a question to you, like, why do we write tests? There are a lot of really good reasons to write tests. And, you know, probably you want to reduce bugs in your software, so when you make a change, it doesn't cost you a whole bunch of money. For me personally, I get a ton of anxiety when I come across a module and there are no tests for it. Like, the very first thing I do is write tests to make sure that I don't break something. And so, kind of a bold claim, but most of the tests we write are to prevent regressions in our software. We don't write tests to uncover flaws in our software. And so Dijkstra once said that program testing can be a very effective way to show the presence of bugs, but it is hopelessly inadequate for showing their absence. Right? It's not like we never have bugs in our production software. Like, we get that, and people report bugs. You know, maybe customer service comes to us and says, we got this bug, we have to fix it. So bugs sneak into production. And the reason why bugs sneak into production is because we cannot test everything. Right? There are limits to the level of testing that we're doing that causes these bugs to sneak in. Otherwise, we would have caught them. And so a test case is really only as good as the data that you're using. And when your program becomes sufficiently complex, the inputs become complex, and therefore it becomes much more difficult to have good data in your test. So tests prevent regressions, but tests only prevent regressions that you know about. Right? Like, how can I write a test for some flaw in my software that I don't know I have? And so this is what we typically do with example-based tests. So we're going to start with this. We're going to go over to another extreme, and we're going to find a nice middle ground. And this is what we usually do. So we're going to start simple because I think this sort of gets the idea across, and then we'll move on to a more real-world example. But say you have a sort function, and so this sort function is just going to take an array of numbers and return an array of numbers, right? And presumably they're sorted. So we'll write some tests for that. The first one might be, well, I expect that if I pass in an empty array, I get back an empty array. If I pass in the array 6, 2, 1, I get back 1, 2, 6. And if I pass in something that's already sorted, I get back the same thing because it doesn't need to be sorted again. And like, these are good, right? But in the end, if we think about all of the possible data points that we can have, we're really only picking one. Out of the entire set of everything, we're taking one data point for each of those different cases. And so if example-based testing is on like this extreme, then on the other extreme, we have fuzz testing. And like, the most naive way to define this is like, say I have a function that says, give me an array of random numbers, right? I don't care what I get, I just want an array of random numbers. And I'm just going to pass it into my function sort, and it's not going to throw. That's all I care about. Of course, this is very naive, but the thing is that if we ran this test enough, then the set of all possible inputs that we get then becomes larger and larger and larger, and we start to cover this circle here. And eventually, you'll get to the point where you're convinced that this is not going to blow up. At least that, right? So wouldn't it be great if we could still use that function, that array of random numbers, to generate our inputs, and still be able to do some check? Like we expect that we sort this and it's equal to something. But the problem then becomes, if I don't know what my input is, how could I know what my output was? Right? When I call this function, I'm not going to get back 621. I'm going to get back, I don't know, something. So I don't know the data ahead of time. And so this is sort of where we get into property-based testing. And so a property is some logical truth about a system under test that is going to hold for all inputs of a given type. So part of the trade-off here is that properties themselves, as we'll see, they become a little bit more nebulous to define. It's not so clear-cut as this thing equals this thing. It's a little bit more vague, and that's because the inputs are not known ahead of time. So I have to be a little bit more vague about my expectations. So here's some examples. Say I have an array of random numbers. If I sort that array, it doesn't change its length. If I have an array of random numbers and I sort it twice, it's the same thing as sorting it once. And if I have an array of random numbers and I sort it, then the resulting array is going to have numbers going upward in value. So the first value is always going to be less than or equal to the next, and then the next will be less than or equal to the one after that, and so on. Right? That's just what a sorted array is. And so if we did this enough, of course, we get this distribution of possible inputs and become more and more confident that these properties are going to hold. And so Jessica Kerr, she gives a lot of talks on property-based testing, and she gave one a few years ago at the Midwest conference, and she said that example-based tests are very narrow in their input and broad in their expectations. So I have that exact array, 621, and I get back exactly 126. So I'm saying just this one little sliver of data in, and I'm saying it has to be exactly this. Fuzz testing is like the opposite, right? Like it could be any input, but I have like no expectation about what the result is. It has to work, like that's it. So property-based testing is somewhere in the middle where we're very broad in our inputs. It could be any array, but we're narrow in our expectations. So there isn't no expectation, there's just a smaller expectation. And so it's sort of this cross between examples and fuzz. So, I don't care about the input as long as it's valid, but I still want to make assertions. And this idea originally comes from QuickCheck, a library originally written in Haskell. And so there's implementations of this in like all mainstream languages. You can just check it out. Like JavaScript has like 10, of course. And so it goes that given some property of a system, we should attempt to generate sets of inputs that would cause that property to fail, to expose a flaw in our code. So it's actually generating the test cases for us. And if it does manage to find some failing input, what it's going to do is it's going to work backwards to locate the simplest failing case. And this last step is actually super, super important, and I'll tell you why. Let's say for my sort function, I called my array of random numbers function, and I got back an array with 2,000 values in it. And I pass that into the sort, and it blows up. And then my test runner comes back to me, and my test runner says, well, we blew up, and here's the array that did that. Like, if I look at that, I have no idea what caused that to fail. My only guess is that it was too long. Other than that, I'm just totally clueless, right? So we have to be able to shrink that down to something that shows us a little bit more like concrete evidence about what is going on and why is that failing. Okay, and so I'm going to be talking about, or I'm going to include TestCheck.js, which is a transpiled version of TestCheck, which is a Clojure core library that's been passed through ClojureScript and then wrapped with like a really nice JavaScript wrapper so that you can do it sort of JavaScript style. It's really nice. And a common theme with all of these libraries is that there is some deliberate randomness here. So it may seem that the values we're getting back are completely random, but that's not exactly true. There's a deliberate mechanism going on in the background. And what I mean is that, like, remember that array of random numbers function? Well, it just returns an array of random numbers, and it's a one-off every time. So every time I call this function, I could call this 1,000 times and possibly never get an array that is length less than 50. So there's no coordination going on behind the scenes, but with libraries like QuickCheck and with TestCheck, there is this deliberate randomness. It's a search for failure. So you might say that depending on the context, an empty array is a different kind of array than an array with 1 value or an array with 10 values, depending on how it's being used. Or if we're talking about people's age, then the number -1 is definitely not a valid value, and so we need to check for that. And so this is accomplished with generators, and what generators are just a way for you to compose these data structures together so that you can represent what random value you would like to have. So you sort of give it the types that you want, and when you pass it into the runner, it will generate random values for you. And some examples of this would be, if I use gen string, I could be able to generate some strings. If I use gen int, I could generate some ints. If I use gen bool, you get it. And then we can compose these things together, like I said. So I could call gen.object, and so that allows me to generate generators for objects. So now I have the name key and the age key, and so this would generate objects for me that are people, I guess. For our sort function, we could use something like this, where we say I want a array of integers, right? And then if I use this with my runner, it would give me back an array of integers every time. And then you can compose things that are already composed, etc. So a sample of what this would look like, so if I took that array of integers, I would get back something like this. Just random stuff. And if I tried my person generator, I get back something like this. So it's kind of all over the place. And you actually notice the first thing it tries is an empty string and 0. And so it's pretty easy to integrate with your favorite test frameworks. There's like an integration for all of them with Jest, which is what I use. There's a library called Jasmine Check, so you just do a quick install step and then you're good to go. So your test can go from something like this, where we have that array of random numbers function, to this, where we now have a function check it instead of just it, and we also pass extra arguments, which are our generators. And then those generators resolve to values that get passed into that function. So we see that R there, which is the array that gets generated. And this will run several times. So by default, I think it's 20. You can set it to whatever you want. You can set it to 2,000 if you like, So we could do this for all of our tests for our sort function. And so because I have 3 tests here, it would generate 60 tests by default. And if I run this, I get a failing spec. And you see that what it says, so I deliberately, I goofed on purpose. So you can see right there that the case that caused it to fail was -7, -7. And it doesn't keep the same length. If I run this again, then I'm going to get the same thing. Like, it fails. Now it tells me that my failing case was 1, 1. And if I run it one more time, I get it again, and it's -4, -4. And I guarantee you that it didn't just come up with this value. It wasn't just like -4, -4, try that out. It managed to generate a bigger array, and it saw that there were 2 values that were the same number, and that caused it to fail, so then it worked backward from that to figure out what was wrong. And I alluded to this before. This is called shrinking. And so this is sort of the raw output that test check gives you. So you see that it actually failed with an entry with 5 elements in it, and it worked backward to one with 2. And this is like super useful, right? And I hope you can appreciate how useful this is. Like, this is a silly example, but it's specifically because I don't have to say anything about the input. Right? I don't have to generate those test cases. The framework does that for me. I just say that these are some truths about the outcome. Right? So it generates the test cases. And, I just say that this property should hold for all inputs of this type. And when you do this, it's actually, it's shocking. You start to uncover bugs in your code. Because, again, when the inputs become sufficiently complex, you start to generate data that is something that you could never even think of. Right? Imagine having 200 unit tests for a single function. Right? We're just not going to do that. That's a nightmare to maintain. It's too much work. But of course, where does this fall apart in JavaScript? Why isn't this more popular? And the answer is that this falls apart in real life. So when you try to use this outside of a toy app, this completely falls apart, and I'll show you why. So I'm going to use a little bit of like flow type declarations here, but say you have that same thing that we talked about before, a person, where you have the name, which is a string, and the age, which is a number. If you had a function save person, I can easily generate input for this, right? My person is very simple, and we've already seen this. I generate my person like that, and then I'll generate values and do my property thing. But what if you have something like this? This is the God object for a project that I used to work on. And it's huge, and there's a lot of fields here, and I'll just highlight a few to show you some of the complexity. This has actually been versioned 10 times. So there's a hard-coded schema version in this type definition. And so that we do this because like we deprecate fields or we change the name or sometimes a subtype changes or something like that. And so we want to make sure that we know exactly what version of this type we're getting. And then if we look at like some of these subtypes, the trigger like is also non-trivial. The trigger is just like this mishmash of stuff, and it's actually a tagged union. And what a tagged union is it's a list of possible shapes that this trigger could have, but it can only be one of them at a time. So it can only ever be an exit trigger or a welcome trigger and so on. And then in addition to that, we have this type called any activation rule. And so any activation rule is the tagged union of all of the versions of the activation rule. And for reasons that I won't get into, like we have to, when the user saves their activation rule, we may not be saving the latest one. And that's just because of how they're stored and how we have to access them. And if you're totally confused at this point, like that's perfect. That's exactly what I'm going for. I want you to be confused because this is what happens in real life, right? This is what happens when we have a high degree of complexity and these programs grow organically and our requirements change organically. We end up in situations like this. So as a team, we protect ourselves from this by having a function called upgrade activation rule. And so what upgrade activation rule does is it takes a version number, the version that the program consuming this needs, and it takes an activation rule and it upgrades it to whatever that version is, or downgrades it, because it may not actually need the latest version. And we do this at the boundary of our program so that the rest of the program can just assume that there's one type of activation rule. And so, well, okay, if we write a test for this, we do have a property, and it's that this needs to be backwards compatible. So if I generate a random activation rule with a random version, and I upgrade the activation rule all the way to the max version, the latest one, and I downgrade it back, then the upgraded, downgraded one is the exact same as the original one. And this is a perfect candidate for this property-based testing. Okay, so why don't we create a generator for our activation rule, since that's how you do it? Okay, well, it's an object, and you have some, trivial fields. And then you try to create the generator for the trigger type, and you're just in over your head immediately. So the generator is one of this object or another object or another object, and it very quickly gets out of hand. However, this is sort of necessary, right? Because these things, like if we want to find edge cases in this code, we need to have these sorts of mechanisms in place. Like we have to use this. Otherwise, we're going to get bugs, and we cannot have bugs in this piece of code. So it's awful to maintain. And the reason why it's awful to maintain is that, of course, the generators are not synced with our type definitions. Like I already know what my types are, and my program is consuming those types with flow, but I don't want to have to define them in two different places. So to get around this, what we did was we created a Babel transform called Babel plugin transform flow2gen. And this is open source, and you can go and look at this if you want. It does what we want, so like if you have issues with it, I probably will not merge your pull request. But it's really easy to integrate. You just add it to your test plugins before you strip your flow types. And then what it does is exactly what it says. It transforms your flow type definitions to generators. And so you get this object, and you just call toGen on it, and then it creates a generator from what was your type definition. And so that previous property that we had becomes this, where we're now just passing in activation rule to gen, any activation rule to gen, and then we're using that in the function. And again, it runs like 20 times. I think actually we have this run several hundred times just to be sure every time we make a change to this code. So, when I did this for the first time, when we initially integrated the Babel transform with our test suite, I found so many issues. Like I spent days fixing our code because there were so many issues. And actually, a lot of them were generated from type definitions that were just too loose. So we did not we just assumed that a type was a certain way and that we would never use it in an incorrect way. But the generator doesn't really care about that. So some outcomes here. Generating generators generates success. So the only reason that we continue to use property-based testing right now on these projects is because of this ability to generate generators from our type definitions. So previously, tests and typing, these were two different validation processes, and this sort of like marries them together. So now the two sets of expectations are the same. So before you could fail the typing, but then the test would pass, or you could fail the test, but then the typing would pass. Like it's super annoying. And not only that, like you're not even sure if your generators are generating like the total gambit of like possible valid values that could be passed into this function. The second is that it like I said, it locks down your type definitions. So sometimes we were too permissive, and like it would generate things that we like colloquially would never expect. We just never expect these values. And like a quick example of something that occurred is like, say you have some function, and some function accepts an array of strings, but it is knowledge amongst the developers that this is always an array with 3 values in it, every time, for whatever reason, right? These sorts of things happen. And if we were to take this type and then turn it into a generator and run it through, like it would immediately fail. Like almost immediately, the first thing it's gonna try is an empty array, and it would break. So you need to change it to something like this. It has to be 3 strings, right? And this is much tighter. Now that knowledge is no longer codified up here. It's now directly in the code, and it forces you to be much more explicit. And so this tightens up your types, which sort of tightens up your API. The next is fuzz testing. So I talked about fuzz testing at the beginning, but this lets you do it like super easy. Say, for example, I'm using React and Redux. I could generate a random initial state and then generate a list of possible actions and then just say, well, create my store, mount my UI using that store, and then just dispatch all of those actions and see if I get an error, right? And so then also to make this easier, what we did was we added a static member to all of the functions in your program, only in the test suite, called toGen. And so if you called that, what you get back is the arguments array for the function, so long as all of the inputs are typed. So in this case here, you would just get back an array of numbers, but it can be anything. Okay, so some things that suck. You can't type check your tests anymore if you care about that. That's like gone out the window because now you're using types as values, and if you want to flow check your tests, like it's just going to barf on you. So you can't do that. People who come to the team have to know that you're doing this, of course, and like this is a hack, right? This is a way that we can achieve property-based testing with a very little effort, but of course there are hacks because JavaScript isn't made for this. It's very, very slow. So, we run this property for our upgrade activation rule function, and it takes something like 20 seconds. If you're doing TDD, you're not going to get the very quick feedback that you're expecting, especially if it fails. If it fails, and then it's trying to work backward to figure out what is the minimum failing case, it's going to take a long time. And this is not some sort of silver bullet. You still need to use this with proper unit tests, right, to make sure that your program works as you expected with very specific inputs. But it can uncover a lot of bugs for you, like I said. So, recently, TypeScript and Flow have made it so that it is now possible for you to ensure that your generators are giving you back the proper types. So perhaps you don't need this. TypeScript calls them mapped types. In Flow, I think you got to use those weird, undocumented, like probably deprecated secret types that they have. But you can get around this. You don't need this, but it's still kind of a pain to maintain. So the conclusion, the point that I want you to take away is that property-based testing finds flaws in your code for you because the computer comes up with the test cases. And it does them much faster than you can. And so in the next year, I think we can really do a lot of work to make this sort of thing easy to do in JavaScript. Thanks.
Gabe, thank you very much. Now let's have a look at the questions. So the first one is, can you share your views on a test first or TDD?
Okay. It's good. It's fine. I don't know. I don't do it often. I look at like unit tests or integration tests as a form of like preventing me from creating issues or the next person from creating issues in the future. So I don't often do TDD, and I find that it can get in the way if you're trying to design something. Yeah.
What do you think about putting logic into the test? Who tests the code of the test?
I have no thoughts on that. I don't even know what to say.
Okay. As you shared your idea on how long it takes with your test, we're going to skip this one. Do you consider a good idea to write logic inside tests? With it? Okay, we're repeating each other. Okay. How does it work with just component snapshot?
Yeah, okay, that's a good question. So what you can do, if you really want to use snapshots, what you can do is one of the options that you can pass to the runner on a per check it basis is that you can give it the random seed that it uses. So usually it generates a random seed and then it bases the inputs off of that random seed. So I guess you could set the seed, and then that means that the generated values will always be the same. So if you do that, then you can just snapshot everything. But I found that as soon as you change the generator, your entire, it gets very loud.
And what is the difference between this and Faker.js?
So Faker just gives you nice to look at values, right? Like this is like literally generating garbage values. It'll even use special characters in a lot of cases to try and fool, whatever logic you have. Faker is just about, I want a nice name, so generate me a nice looking name. It's never going to give you, or perhaps it does, but deliberately going for empty values. It's more about generating nice fake data.
And can random data make it difficult to reproduce a test fail?
No, because you're told what the failing output is, so then you can just rerun the test.
Okay, time for 2 more questions.
Sure.
So you think it would make sense to provide / integrate real data, phone numbers, country names, etc.?
If you absolutely have to, yeah, but you could generate all of that information as well.
Okay, last question is, do you have TypeScript support?
No, so I long time ago stopped working on this because we actually we're switching all of our JavaScript to TypeScript. And so the plugin is basically dead. It would be nice to use it with TypeScript. I think code generation is probably the way that we'll go. If I had to re-implement it, I'd do a code generation instead of a transform, because the transform kind of gets in the way. With code generation, you can just generate some files and then require them like that. So that's how I will probably do it if I re-implement this for TypeScript.
And the last question, a bonus one, where to look to get started with this?
You could email me, or you could go look at the README. I think it does a decent job of sort of explaining how it works, but yeah, come find me. I'm not hard to find. I'm wearing the internet shirt, so.
Great. Gabe, thank you so much. Yeah.
Awesome.
Thank you.